Hello everyone, this is lecture 52 of the course Process Equipment Design and I welcome you all in this lecture. And as far as this lecture is concerned, we are going to discuss the distillation column, and for that process design is considered. Okay. So, from last week we have started this topic, and if you remember the last lecture, there we have discussed plate efficiency. Okay. And as far as this process design is concerned, we have already covered number of milestones as distillation and continuous process. Here we have revised the distillation process and discussed the continuous process, and then we have designed the distillation column considering binary system. Designing means here we have considered the number of trace calculations, right, and that is done through McCabe-Thiele method, and that is basic method for design of binary system. And then we have discussed multi-component system, where number of trays we can identify based on different methods. Okay. And after that we have covered the plate efficiency, which is basically the last lecture, where column efficiency as well as plate efficiency are discussed, and there we have discussed detailed method of it, that is AICHE method. Okay. So, in this way you can consider the plate efficiency considering geometry as well as mass transfer characteristics within the plate, right. And after that we have the topic plate hydraulic design. So, from now onward we will focus on this topic, that is plate hydraulic design. It means how to design a plate, what are the parameters and what other factors we should consider while completing design of a particular plate. But before that we will focus on plate contactors. It means how many types of plates are available and at what condition which plate should be selected, right. So, let us focus on plate contactors. So, as far as plate contactors is concerned, we can discuss that with the help of this schematic. If you see here, I am having the plate, right, and in this plate this section is basically called as weir, okay, and this section, or we consider this particular section, it is called as downcomer, fine. So, liquid is basically coming from upper plate from downcomer to the lower plate, and if you consider this particular section as well as this particular section, their sheet is uniform, okay, and in between this we can find the holes in the plate, right. So, as far as this plate contactor is concerned, we can have only this much area as active area. Okay. Active area means where liquid and vapor contacts occur. Okay. So, you see when the liquid is coming down, it is moving in this direction over the plate, and when it will cross this weir, it will start falling down. Okay. And as far as vapor movement is concerned, it is coming from bottom, okay, and through these holes it comes into contact with the liquid which is available over the plate, and when the liquid and vapor contact occurs, we have froth formation also. So, some foam or froth will be there over the plate, right. So, here basically we have the mass transfer activity, and after that disengagement of vapor and liquid occurs. Liquid comes down and vapor moves up to plate just above to this, right. So, in this way liquid and vapor contact over the plate, and if I consider this particular section and this particular section, which is basically the part of the plate, but it is not having the hole, right. So, vapor is not able to move from this section as well as from this section. However, when vapor is coming from the bottom, it covers the whole plate, right, but passage to move upward is available within the active zone only. Okay. So, this zone basically we call as calming zone, and this is the downcomer, and this section we particularly call as downcomer apron. Okay. So, in this way liquid and vapor contact occurs over the plate and so the mass transfer activity. Okay. And as far as this flow is concerned over the plate, you can consider that liquid is moving in this direction, however, vapor is moving from bottom. Okay. So, this is nothing but the cross flow over the plate. Fine. So, as far as cross flow plates are concerned, these are most common type of plate contactors used in distillation and absorption columns. Okay. In a cross flow plate, the liquid flows across the plate and vapor up through the plate, as we have discussed that this type of movement occurs over the plate, right. The liquid which is available over the plate, it flows down and moves from one plate to another plate through a vertical channel, and that vertical channel we call as downcomers. Okay. So, a pool of liquid is retained on the plate by an outlet weir. Okay. So, this is basically outlet weir. Okay. So, how much height of the weir we consider, based on that we consider what should be the hold up of the liquid over the plate. Okay. So, how much volume of the liquid can be accumulated over the plate, that can be decided by the height of weir. Okay. So, as far as practical plate contactors occur, okay, it means what type of plate contactors are actually used in distillation column and absorption column. These are basically of three type. First is the sieve plate, then we have bubble cap plate, and then we consider valve plate. Okay. So, in this way we can have sieve tray, bubble cap tray and valve tray. Actually, we consider this plate as well as tray, which are basically synonym to each other, right. So, any word we can use while discussing. Okay. So, as far as these plates are concerned, we will consider each type of plate one by one and discuss its merit as well as demerits, and then we will focus on the selection of proper plate depending upon the process condition, right. So, let us start with the sieve plate. However, when we focus on the plate, apart from sieve plate, bubble cap tray as well as valve tray, we have another type of trays also, such as showers plates. Okay. So, these are basically plates which does not have any downcomer. Okay. So, non-cross flow occurs over the plate. Liquid is basically showering down the column through large opening in the plate. Okay. And therefore, it is called as shower plates, or we consider that as a shower plate also. These and other proprietary non-cross flow plates are used for special purposes, particularly when a low pressure drop is required. Okay. So, you can consider that pressure drop on the plate is basically occurring when I am having hurdles while passing the fluid. Okay. So, when I am not considering downcomer, so that section is particularly eliminated. So, we consider that no friction is occurring there. So, pressure drop will be reduced, right. So, in that way we consider the showers plate, and now onward we will consider the usual plates, that is sieve plate, bubble cap plate as well as valve plate, and let us have the discussion on sieve plate. So, as far as sieve plate is concerned, this is basically the simplest type of tray which we consider in cross flow contactors, and when you see the image of this, it will be like this. Okay. So, it is basically the plate where simple holes are there. Okay. And if you consider this section here, solid plate is there, no pores are available. So, this is the area where liquid is falling from upper plate, and this is below the downcomer section, right. So, liquid is basically falling over here, it will be stable and then it will start moving in this way. Okay. And from bottom we can consider vapor flow, right. So, cross flow occurs over here, and because its geometry is very simple, we have holes over the metal plate, and therefore, it is called as simplest type of plate, and this type of plate we call as sieve plate, right. And now, if you consider this section where you are finding some opening, okay, and as per the requirement this particular section can be opened, okay. So, this basically we call as manholes, okay. As far as sieve plate is concerned, it is basically the cheaper type of plate in comparison to bubble cap as well as valve plates. So, as far as design is concerned, it is simplest type, and cost is concerned, it is cheapest among all three, right. So, sieve plates are simply metal plates with holes in them, okay. So, as we have already seen in this image, okay. So, if you focus on this, this is basically weir, and this we call as the weir height, and if you see the bottom section, it is nothing but the downcomer apron, okay. So, in this way we consider the construction of sieve tray. So, simplest as well as cheapest, that you have to keep in mind about the sieve plate. So, simplest as well as cheapest, that you have to keep in mind for sieve plate, right. Further, this image you can see where you can find the holes closely, okay. So, this is simple, the metal sheet where close. So, here we have the metal sheet where holes are available like this, you can see, and for details you can go through this link about the sieve plate. So, further let us consider few more points about sieve plate, and this is basically in the sieve plate, vapor passes straight upward through the liquid on the plate, as we have discussed previously also. So, apart from all these advantages, we have some disadvantages also for sieve plate, and that disadvantage is, as there is no vapor liquid seal, so there is chances of weeping in lower flow rates, which reduces the plate efficiency, okay. What is the meaning of this? When we consider the sieve plate, you can see that it is only the holes over the plate, right. So, these holes are not covered. So, whenever I am having lower flow rate of liquid, it means liquid will stay for longer time over the plate, then liquid will start moving down from the holes, okay. But you understand that these holes are basically formed for the movement of vapor, fine, in upward direction, but not for the liquid. Liquid has to move like this, okay. But if we face this condition where liquid is start falling from these holes, this condition we call as weeping, which is not desirable as far as mass transfer process is concerned over the plate, right. So, that is basically the disadvantage, and that you can also imagine from this schematic. Like here I am having the vapor which is moving from downward, right, and this is basically the normal operation where liquid is available, and then whatever vapor is entering from the bottom, it will be available in the form of droplets, as you can see in this diagram, right. And further, if weeping will occur, then what will happen? We can have vapor from the bottom, okay, but liquid will also start coming from these holes, okay, which will hinder the movement of the vapor to upward direction, fine. So, in this way, when liquid will start falling down from these holes, this condition we call as weeping, which is highly undesirable. So, as far as design of plate is concerned, this condition must be checked, and if it is occurring, we have to consider some measures to stop this, and what these measures are, that we will discuss in due time, right. Further, we consider that it has lower fixed cost as well as lower maintenance cost, because simple holes are there. So, fixed cost will not be very large or very high, because we consider only the metal plate, right. We do not have any extra assembly to invest the material, okay. So, fixed cost will be less, it means fixed cost means the cost of material as well as the cost of manufacturing, okay. And therefore, we consider that it is the cheapest plate in comparison to bubble cap as well as valve tray, okay. So, let us see the design parameters for the sieve plate, and these design parameters are the arrangement, it means how holes are arranged, and number, how many holes will be there, and size of holes. These will be the design parameters, and how we make the holes in the metal plate, and how we make the holes in the metal plate. All these points we have to consider while designing sieve tray. Okay. So, in this way you can observe the functioning of sieve plate, its advantage as well as disadvantage. Now, let us focus on another plate, and that is basically bubble cap tray. Okay. So, as far as bubble cap tray is concerned, in this type plates are having number of bubbles cap. Okay. So, what is this bubble cap? It is basically the cap which has some sections where we can form the bubble. Okay. To give an example, here we have the bubble cap. Okay. So, this is basically the cap, complete cap is there, where I am having these type of holes, right. And when vapor is coming, vapor is entering into these holes, and then it will be converted into bubbles, and then it will interact with the liquid over the plate. Okay. So, in this way it is called bubble cap. Cap is there, but bubbles are formed when vapor enters from these openings over the cap. Okay. So, further, if we consider the bubble cap, a bubble cap tray has riser or chimney fitted over each hole and a cap that covers that riser. Okay. That we can understand from this schematic. If you see here, we have the hole. Okay. We consider hole in this way. So, this is basically the hole frame. So, this is basically the hole from where vapor is entering, and you consider over this opening we have this type of chimney, or we can consider it is a, or we can consider that it is a type of nozzle which is fitted with the hole. Okay. So, when we consider this section, it is the, in this bubble cap it is called as the chimney, but it looks like a nozzle. So, what will happen over this chimney, this type of bubble cap sits. Okay. So, this cap is simply available over the chimney. So, if we see this complete plate, it is basically like some caps are there. Okay. How it will look like, that we will also discuss. So, what will happen when vapor is entering from this? Okay. So, this space is completely open for vapor to move upward. Okay. So, when the vapor is moving from this empty space, it is coming to this region. Okay. And this region is also have some space, because cap size is, because height of the cap is higher than the height of the chimney, right. And from this space it does not have any other passage than to move in this direction. Okay. So, from this hole vapor coming out, and here we have the liquid, right. So, vapor which is coming out from these hole, it is coming into contact with this liquid, and when this vapor is exiting these small holes, as we can observe over here, it is converted into small bubbles, and that bubbles are basically come in contact with the liquid, and mass transfer takes place there over the plate, right. So, in this way we can understand the complete assembly of the bubble cap as well as its functioning. Fine. So, the cap is basically mounted, so there is a space between riser and cap to allow the passage of vapor, that we have already discussed, and vapor which is available, it rises through the chimney. Fine. That we understood through the schematic also, and it is directed downward by the cap, like this section or this section or this section, and finally discharging through the slots in the cap, and these are basically the slots, and finally bubbling through the liquid on the tray. Okay. So, all these points we have understood through the schematic. Now, if you see Now, if you see, the most significant feature of bubble plate is that it uses the riser, okay, and that riser is basically stopping the liquid from coming to the plate through the hole to downward, right. So, that chimney as well as riser is working as the stopper for liquid to move downward, and therefore, weeping is not possible in these type of trays, right. And when we consider very low liquid flow rate, then also liquid is not able to move from the slots of the cap to the chimney and so through the hole, right. So, the basic advantage of this tray is that it can be operated with very low flow rate of liquid, right. If you see the complete bubble cap tray, it is looking like this. So, we have small caps over the plate, right. And now, let us discuss the valve plate. As far as valve tray is concerned, these are basically advanced version of sieve plate and it contains larger diameter holes. Okay. So, if I am having larger diameter holes and it is basically like sieve plate, so it has more tendency for weeping, right. But no, this is not the case, because each hole has some cover, okay, and that is why it is called as advanced sieve plates. So, in valve trays, perforations are basically covered by liftable caps. So, that you can imagine from this image that each hole is basically covered with the cap, and these caps are basically liftable caps. How it works, that we will discuss. So, vapor flows which is coming from the downward, it flows and lifts the cap and thus self creating a flow area for the passage of vapor, okay, and that we can understand from this schematic. If you see here, when the vapor is coming from downward, it basically pushes this cap upward and make its own path from this, right. And for low vapor, we can consider, for low vapor flow rate, we can consider that it will not able to lift the cap properly. Okay. So, what is the case, that if low flow rate of vapor we are considering and it will not able to lift it properly. So, it will basically stopping liquid from moving through the hole to downward, right, as we had the disadvantage in sieve plate. Okay. And as far as high vapor flow rate is concerned, it can lift the cap upward. Okay. So, as the flow rate of vapor will be there, we can get the sufficient space for vapor to move upward, otherwise it will not able to lift the cap upward, and so weeping can be stopped. Fine. So, this point we have already covered, that lifting cap directs the vapor to flow horizontally into the liquid like in this way, and better mixing is occurring in comparison to sieve plate, because it is basically in this way and then in this way. Okay. However, in sieve plate only we have the vertical movement of vapor. Okay. Further, valve tray can operate efficiently at low flow rate than sieve plate, and valves are closed at low vapor rates. So, weeping can be avoided. Fine. So, you can see the valve plate closely from this image, and for details you can go through these links, and as far as that cap is concerned, it is basically looking like this. Okay. So, in this way we can have the valve tray. Now, let us see how to select a particular plate depending upon different parameters. So, first of all we have the cost. So, as far as cost is concerned, that you can understand that bubble cap has maximum investment. Okay. Valve tray is lesser than this, and sieve plate is the simplest and cheapest, that we have already discussed. So, as far as material of construction involved in the mild steel when we are making bubble cap, valve plate and sieve trays, this ratio we basically follow like 3:1.5:1. So, maximum cost of material can be considered in bubble cap, and the reason you can understand. Next, I am having the capacity. There is a little difference in capacity rating of the three type, and rank varies from sieve plate, then valve, and then bubble cap. Okay. And as far as operating range is concerned, operating range is basically the meaning of the flow rates. Okay. So, as far as bubble cap tray is concerned, that can be operated with very low flow rate. Fine. So, that is the advantage of bubble cap. However, if operating condition is mild, okay, we should choose sieve plate. Okay, if we can avoid the weeping through sieve plate. Okay, and that will be depending upon the vapor flow rate which is occurring in the system. Okay. So, basically sieve plates rely on the flow of the vapor through the holes to hold the liquid on the plate and cannot operate at very low vapor rates. Okay. But in that condition we can have bubble plate. But with good design, sieve plates can be designed to give satisfactory operating range, and typically it is 50% to 120% of design capacity. Okay. So, there is a flexibility also with the sieve plate, but main disadvantage is it cannot be operated for very low vapor flow rate, and in that case we should select bubble cap, right. And as far as valve plates are concerned, these are intended to give greater flexibility in comparison to sieve plates at lower cost in comparison to bubble cap. So, when we have the choice, we can choose the valve tray first in comparison to bubble cap. However, when flow rate is very small, we should consider bubble cap. We do not have any other choice. We do not have any other choice, right. So, next point we have is the efficiency. The Murphy efficiency of three types of plate will be virtually the same when operating over their design flow range, and no real distinction can be made between them. So, as far as efficiency is concerned, it is almost same for all. And next we have pressure drop. As we have discussed that pressure drop is basically causing by the friction which is generated when movement of vapor as well as liquid is occurring. Okay. So, when this friction will be maximum, where I am having maximum hindrance, and where I will where I can consider maximum hindrance, obviously in the case of bubble cap. So, bubble cap plate has highest pressure drop. However, as far as lowest pressure drop is concerned, it will be obviously for sieve plate. Okay. So, conclusion is sieve plates are cheapest and are satisfactory for most application. Valve plate should be considered if the specified turn down ratio cannot be met with the sieve plate. Okay. Turn down ratio is the ratio of maximum flow rate divided by minimum flow rate. Okay. So, and bubble caps should only be used where very low vapor rates have to be handled, and a positive liquid seal is essential for all flow rates, right. So, in this way we should choose different type of plates depending upon the conditions, because you know the merits and demerits of all these type of plates. And here we have some flow patterns as far as liquid, and here we have some flow patterns as well as liquid movement is concerned. And here first of all we have single pass, it means how the liquid movement occurs over the plate. Okay. So, if you consider here liquid is coming from the top, moving over the plate only once and then coming down, fine. So, this is basically single pass plate, and in most of the cases such type of flow patterns is considered, right. And second we have the reverse flow. Okay. If you consider here liquid is coming from the top only in this section, okay, because at the middle we have the partition, fine. So, some strip will be there, some metal strip will be welded over here, and here we have the exit weir, fine. So, liquid is coming from this. So, liquid is coming to this side from upward plate, and then it is moving in this way, and then from here it moves down. So, this is basically reverse flow plate where entry of the liquid and exit of the liquid is occurring at the same space or at the same side of the plate, right. And this is basically used when I am having low flow rate of liquid. So, by partitioning the plate from middle, we can basically reducing the flow area, and so we can increase the velocity of the liquid over the plate, right. However, if flow rate of the liquid is higher, it will not able to cover the. However, if the liquid flow rate is very high, we can consider this double pass plate. It basically divides the liquid in two different direction. Fine, that you can clearly understand from here, like liquid is coming from the top in this way, it flows in this direction, and here we have the exit weir, and after that it is moving down from this space, okay, and then from this space, and then it enters to second plate from the bottom like this, and then further coming down like this. Okay. So, this is basically double pass plate, and here we have some plate constructions and we will quickly cover it. Here you see, when the liquid is coming over the plate, it is basically the section where holes are not available, and so it is called as calming area. Okay. And here we have the metal sprit, and here we have the metal ring which we call as the support, and over this support tray lies, okay, or tray sits. Okay. And when the size of the diameter is very large, we prepare this plate in different sections, and these are attached over the beam, as you can observe here. Okay. And as far as this thickness is concerned, beam and rings are usually 50 mm wide, and we usually consider spacing between trays as 0.6 meter. Okay. So, we have different other spacings also that we will consider in detailed design, right. And now we will focus on the downcomer. You can see different types of downcomers are there: vertical apron, okay, inclined apron like this, okay, and here we have inlet weir also, like from apron liquid is coming down, and then here we have some restrictions. Okay. And after that the movement of the liquid over the plate has more turbulence. So, we can have better mixing over here, and similarly I can have the recessed wall, okay, as you can observe here. Okay. So, in this way we can have different types of downcomers, and as far as plate contactors are concerned, we have considered different sections which are available over the plate, right, and we will continue the distillation column design from the next lecture onward. So, that is all for now. Thank you.